Hello, in the last videos we discussed about binary search. Let's discuss a problem from Codeforces. Monocarp has installed a new fence at his summer house. It consists of n planks of same size. Each plank will be painted in exactly one color. The number of different colors that the planks will be painted is exactly 2, and the planks that are painted in the same color must form a continuous sequence. Monocarp has m different pairs, and the paint of the ith color is sufficient to paint no more than AI planks of the fence. Monocarp will not buy any additional paints. You have to find the number of ways to paint the fence that satisfy all the given conditions. So constraints of nm can go up to 2 if I and the value of a can be less than or equal to n. For example, the m is 3, the m is 5, and the number of colors is 2. So the first one is 3 and the second one is 4. So let's assume that first paint is A and second one is B. So let's check which cases are possible. Is A, B, 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 and possible? Because it is less than or equal to 3 and it is less than or equal to 4. So this is possible. And similarly, all these are possible because the occurrences of A are contiguous and occurrences of B are contiguous, and there are exactly 2 colors. And these will follow the occurrences, the count of A less than or equal to 3 and the count of B less than or equal to 4. So all these will satisfy, though the number of possible ways is 6. And is AB a BA possible? No, because the B's and A's are not contiguous. And is this possible? No, because there is only one color. Because we must have 2 colors. And is this possible? No, because value of A is 3, so it should be less than or equal to 3, but it is 4. So each will not satisfy condition. So all these 3 are not correct ways to paint, and the answer is 2. Answer is 6 because these 6 are the strings that satisfy. Now we can have only 2 indices because there are only 2 pairs. And now let's think in terms of one color. So let's try to think in terms of one, and let's try to think about the other. So if we are at index I and if its value is less than or equal to vi, then what are the choices that we can take? We can paint one time or two or three and so on up to vi because we can use only less than or equal to vi. So if this is the length of the subarray that we are considering for the first color, what can be the second length? The total length should be m, and this is the first one. So what should be this length? It will be m minus this length. So if the subarray that we are going to paint with the first color is 1, the next should be m minus 1. So similarly, if we are trying to paint 2, the next should be m minus 2 and so on. Similarly, for if we are trying to paint the whole one, then it should be m minus va for the next color. So when can we take a color with m minus 1? It is only possible if vi of that element is greater than or equal to m minus 1. Because if we are trying to paint a color with 7, but if its vi is 3, we cannot paint because it should be less than or equal to 3. So if we are able to take a color with m minus 1, it must have greater than or equal to m minus 1 vi, so that we can take this color. And similarly, if it should be m minus vi of that must be greater than or equal to m of m minus v of I, because only then we can take this color. So even now we have to find the number of values with greater than or equal to x in least possible time, because we have to find the number of colors with greater than or equal to m minus 1 and similarly all. So we should use lower bound because we can sort the array and we can get the least index that satisfies the condition greater than or equal to given number in log n. So we got an idea, so we can traverse the all colors, and fixing that we can find the number of different colors that can be acted as second one. So we are going to the first color, and first color can be colored k in the k subarray. So k is from 1 to v of j, and now we can find the lower bound of the second one, m minus k, and we can get the answer. But the time complexity is n square log n because the two loops are two loops, and lower bound we can find in log n. So the total time complexity is n square log n. But the n and m are 2 up to 2 if I, so we have to optimize it. So let's try to optimize the inner loop, because obviously we have to traverse the all paints once. So let's try to remove the inner one. So what the inner loop is doing, it is just counting the number of answers that is possible to paint all this. So we want sum of some subarray in O of 1, right? So we are trying to start from 1 and we are trying to find lower bound of this and adding to 2 and so on till v of j. So we are trying to find some subarray 1 to v of j with lower bound. So what if we pre-compute lower bound of 0, 1 to 3 and so on till m and do prefix sum of it? So we can do prefix sum and we can find subarray sum in O of 1. So we are traversing 0 to m because the values can be less than or equal to m only. So now we are finding the lower bound of this value and storing this in the vector. So v2 of j represents that the number of colors that satisfy the condition greater than or equal to j, and it will be n minus lower bound, because if we found the first occurrence which is greater than or equal to this, all elements next to it also will satisfy the condition greater than or equal to this. So the last element index is minus 1, n minus 1, and this is lower bound. So the number of elements that satisfies this condition is this minus this plus 1. So it is n minus lb. So v2 of j indicates that the number of colors satisfy the condition greater than or equal to j. And now we pre-computed this, and now we are trying to do prefix sum so that we can find subarray sum in O of 1. So for example, if we want the subarray of sum of subarray I to j, it will be v2 of j minus v2 of I minus 1, because v2 of j will have the sum of up to I minus 1, I plus 1 and so on till j. We want I to j, right? So we have to decrease the before one so that we can get the subarray of I to j. So we try to optimize the lower loop, and now we can try to access this loop whole loop in of 1 so that we can find the answer in of n. But let's take another case. For example, if v of j is k and it is less than m, so what are the possible cases? We can take 1 2 3 and so on till k, because we can use only less than or equal to v of j. So if this is 1, the next color should be greater than or equal to m minus 1, and it should be greater than or equal to m minus k. So what will be answer based on this? We want the subarray sum from m minus k to m minus 1. So it will be v2 of m minus 1 minus v2 of m minus v of j minus 1, because we have discussed that why there is minus 1 here. So for v of j is equal to k, the answer will be this. Answer is equal to this. But what if v of j is equal to m? Are both same? No. Let's take an example. V of j is equal to m. So here, if it is k, we are able to paint till k. But here, can we paint till m? No. Because if we paint till m, the whole plank is completed. So there is no other color. But we should use two colors. So it is not possible. So what if we can use up to m minus 1? Because if we paint this till m minus 1, then there is another color to paint. So even if v of j is equal to m, we can paint only till m minus 1. So it is indirectly like v of j is equal to m minus 1. Because if v of j is equal to k, we are storing from 1 to k. So even if it is m, we can paint only till m minus 1. So it is simply v of j is equal to m minus 1. So we want only the sum from 1 to m minus 1. So it will be v2 of m minus 1 minus v2 of 1 minus 1, which is 0. So if we found v of j is equal to m, we can just try to decrement the value, because it is indirectly m minus 1, because we cannot paint till m. So we found how to find the inner loop. But now, is this correct? Are we done with the solution? No. Let's take another case. The value of m is 5 and the value of n is 2 and the values are 3 and 4, which is the first example. And now 1 2 3. So these are three possible cases, and the second length should be this. So for example, we are finding the answer for greater than or equal to 4. So only second one will satisfy the condition. So it is only B. But now let's come to greater than or equal to 3. So for greater than or equal to case, both A and B are correct, right? Because this is greater than or equal to B 3 and this is also greater than or equal to 3. So both colors satisfy the condition. But this is indirectly we are counting A again in second part also. So we are painting till A, and in the second case as well we are trying to paint this with A, because this is satisfying the lower bound condition. But we must color with a different color, because we have to get at least two colors, exactly two colors. So if we are trying to paint the first one with A, the second one must not be A, it should be another. So we have to subtract the number of times we counted same from the answer. So the answer till before is correct, but the thing that is wrong is we are trying to paint with the same color for A as well. So here it is 2, and even for greater than or equal to 3 we are counting A again. So to remove this answer, what is the correct way? So we have to find how many times we are considering A in the same as well. So that if we decrease, the same answer will be decreased. So let's take m is equal to 10 and va is equal to 5. So these are the values of I 1 to 5, and this should be the second length, which is m minus this. And for greater than or equal to 6, there is no possible value because it is 5. This is not going to consider, and for this case the answer is correct. And now let's try to come to this. So greater than or equal to 5. So this is the first value where our answer is going to same as the present color, because greater than or equal to 5, this color is greater than or equal to 5, correct. So this is the first one where it is A and the second color is also going to be A. So let's assume that it is m minus k, because this is k. Let's assume the least k where the present element is going to come as the second color. So this is k and this is m minus k because the total length is k. So this is m minus k. When this will come, when this will color will match, when this will be v of I, because it is the least possible value which is greater than or equal to this. So k is equal to m minus v of I. So this is the first k where this is A and the second color is same as A. So now we have to subtract the number of times we counted the same. So we got the answer that for 2 the value is repeating. Will the same be happening for 3? Yes, because the this length is increased, so m minus this will be decreased. So it is the condition satisfied for greater than or equal to 5. So it will surely satisfy by greater than or equal to 4, greater than or equal to 3, and so on. Right? Because this is greater than the highest number, so it will be surely greater than or equal to the next number, and so on. So we found the least k, we found the k which is possible, and for all the k's next, it will be possible because 5 greater than or equal to 5, 5 greater than or equal to 4, and so on. So it will be possible till last value. What is the last value possible here? It is v of j, and it will be till m minus v of j because total sum is m. So the number of times we counted the same color is m minus k to m minus v of j. So how many are these? It will be v of j minus k plus 1 because this minus this plus 1. And we found that k is equal to m minus v of I, v of j. So it will be 2 into v of j minus m plus 1. So this is the number of times we considered the same color twice. So we have to decrement this from answer. So if this is greater than or equal to 0, we can decrement it from answer. Because if it is greater than or equal to 0 means, then we are double counting it. So we are decrementing the answer. Hope you understand this. So let's check the code. So we are taking a vector of size m because the values can go up till m only. So we are sorting the vector and we are using lower bound and computing the prefix sum. And initially answer is 0. We are traversing the first color, and if it is not equal to m, answer is equal to this, and if it is v of j is equal to m, this is this. So we have discussed in one of the slides. And if v of j is equal to m, it is indirectly like v of j is equal to m minus 1. So we are trying to decrement it, and now this will become same as some other which is not equal to m. So after 22nd line, all values are same, but there is no occurrence of m because we have decremented it. So now if we 2 into v of j minus m plus 1 is equal to 0, greater than or equal to 0, we are double counting it and we are decrementing the answer. And finally we are putting the answer. Hope you understand this. If you have any doubts, comment below, drop a like. See you in the next video.